So the challenge for me, as I see it, is a threefold challenge. Actually, you have a challenge in science. We need to develop theory and tools, and this I'm talking for myself. Okay, so I work in academia. People in academia have to develop theory and tools that allow free software collaborative development to actually scale up. It is not easy. Then education, you have to train tomorrow engineers to this kind of organizational work. So I don't know if you notice when you recruit people. Still today in academia, we are teaching to our students the same way I have been taught 25 years ago. Okay, so we teach courses, we take algorithmics, so one algorithm, study algorithm, exactly the same as 25 years ago, maybe a more sophisticated. Then write a programming project. Well, okay, you have to write it by yourself. Huh? No copy, no reviews, nothing. So you write 10 lines or 100 lines or 1,000 lines by yourself. Then you have people going and reviewing it. It doesn't work this way, okay? So when you go to a real company, all this, there is a huge difference between the two things. So we should change the way we teach computer science. But this takes time, okay? I'm a professor, so I know the time it takes to make course materials, and actually the situation in France right away, we don't have time to do this. I'm sorry to say it. I hope in other countries you can do it. It's important to train our people in our way. And economy, explain and set up the ecosystem. I mean, the little anecdotes I told you before, in the big company, a small company. Well, maybe make people understand what are the rules of this kind of ecosystem. And here I feel there are many, many things in the lean approach which are very similar, I mean, to this kind of philosophy. You have been trying to explain people something which is very useful, and we have to explain again and again about what are open source ecosystem, which is very important. So now, let me just take a few seconds.
Yeah, you're fine. You're fine.
A few seconds to talk about my interest, okay, science, a bit. What is my vision, actually? Free software is doing something more than just making software cheaper. It is changing the way we will develop and maybe understand software in the future, because software artifacts are becoming transparent. What I mean you no longer have artificial barriers between components or architectural layers. In the proprietary software world, you have these layers because you have interfaces, you have black boxes, you have executable code that arrives, and even if you want to understand what happens inside the executable code, you cannot. Or you can spend a few months with us through the legal department to get an NDA signed, to get access to this particular piece of code, which is a version of 6 months ago, and then you go there and it is 50 million lines. So what are you going to see in these 50 million lines? So you need, it's not the same as really access. Okay. Now these barriers are disappearing. If you want, on this machine, which is running no proprietary software at all, if I want, I could really take Firefox, OpenOffice, Eclipse, whatever. I do something there. I could follow, trace everything that is going through until the last bit. I mean, go to the operating system, down to the assembler level, to the firmware, to everything. I could see everything. This can become transparent. Okay, so there is this theoretical possibility to follow the flow of computation through all the abstraction layers to the last bits in the system. This is exactly what my teachers told me not to do. Okay, so if you want to master complexity, you must not go through abstraction layers. Okay, take it as in the interface and don't look inside. Well, but then you go to industry and you see that if you really do this, it doesn't work because the code doesn't do what the interface says. So you need to have a look, in particular if you are in the safety business or something like this. And this will make it possible to have new levels of quality assurance in the future. If somebody who is an integrator can have control of everything, access to everything, the level of quality assurance can be quite different. I don't say that it will be possible to do it fully. I say it will be possible to imagine to do it fully. And if it is possible to imagine, you know that people are very imaginative. Your clients will probably sometime ask you to do it, even if it is not possible. And then you will probably come to people in academia and say, well, they are asking me to do this traceability of code from here to down to the Linux kernel. How can I do it? And probably will not have an answer because you are still working on one algorithm at a time and one little line of code at a time. So we need theory and tools to make all this process actually work. And I do believe that we should all, but in fact also industry, invest in fundamental research related to free software as soon as possible. So what I mean by this, because this is just marketing, so you want to see some concrete examples. Here are some concrete examples. Actually, in one project we are working on, I'm leading a European project which is called Mancusi. It is managing the complexity of open source infrastructure. We are looking at one of the software artifacts which is probably the most complex system of systems in the planet. A Linux distribution today is a collection of packages. Each of these packages is a package for a piece of software. And this you can see in Debian here, for example, you can see the evolution of the number of packages in the distribution. In the early days, middle of the 90s, a few hundred packages. Today, over 25,000 packages. So it is growing up steadily. And what the other part of us are the interdependencies of the different components of the business. When we are looking into this, and actually together people in Debian, like for example Stefano, who's there, raise your hand. I mean, he's working with me in Mancusi right now. And the point is, if I tell you, you have to master a system that has 25,000 components evolving every day, they change every day, with hundreds of thousands of interrelationships telling you which component needs another component and which component is in conflict with another component. How do you do this? How do you control this kind of complexity? How do you visualize such a system of systems? Well, actually, really, we don't know. This is the reason we are looking into this. Let me give you an example. Okay? You could draw a picture, draw a graph, okay, of this, without no deep knowledge, for example. Well, just draw a picture. Well, I did this. This is the reason why I had to change the presentation. I'm sorry, I had a picture I wanted to have. So there are several components of a desktop environment which is called KDE in a Linux distribution today, and actually in the distribution, Debian distribution back in 2005, you had two of these components, KDE amusements and KDE toys, which are unnecessary, making confusion. They were overlapping with two other components, KDE games and KDE Edu. Well, how can you see they were overlapping? Actually, they are waste in some sense. They have gone away today in 2009, but it took 4 years for them to be detected and removed. But it should be easy to spot. After all, if I use some technology, I can look at these components. There are only 244 and not 25,000, not 25,000 components involved in there. So I just draw a picture. Well, that's a picture. Okay? So, well, it is. I try to make it more real. It is not possible. So you need a really big, huge screen like this. And here there are 244 nodes with all the lines of the interconnection. So good luck to find the problem in here. Okay? Here is where you need science. Okay. So let's try a more systematic approach. We had a look at this. We define a notion, I mean strong dominators in dependency on components. And the picture before just becomes this. And this is the interesting part. You don't care about big mess before. And actually here you see the problem. And this package here, KDE, and this package here, KDE toys, are overlapping with two other packages, this one and this one, that are subsystems. Well, you need to learn how to read this kind of picture. But after a while you see immediately, here is the problem. You go, you spot it, you remove it. So you need to see complexity to master it. If you cannot see it, you have no mastery. And well, if you want to learn more, let's just have a look at what we are doing in Mancusi now. So let me say this again. We need to invest in free software fundamental research, education, education of students, education of communities for ecosystem as soon as possible. And this will be my last words, and I thank you for your attention.